So chapter 9 is everything trig. That's sine, cosine, tangent, circles. We're going to be dealing with that. We're going to be dealing with triangles. I know some of you are like, oh, and some of you think, yay. Try not to think anything. Try to have an open mind. So when I went through the CPM lessons, I really didn't like the way it was organized. So it's going to be a little bit weird, but I decided to make my own. But I wanted to stay true to the CPM curriculum. So you'll notice that halfway through the packet it says Chapter 9 homework. Okay? So that means this first half will be all the lessons, and the second half will be all the homework. This homework corresponds to what I have right here. And don't worry, we'll just kind of pace it and figure out what is the first lesson, the second lesson, the third lesson, the fourth. Okay? So let's start with it. This is going to be a page you want to keep. And by the keep, I mean, well, it's going to be in your packet. But this is a page that will be very useful to you. You already know about SOHCAHTOA. You already know about 45, 45, 90, 30, 60, 90. You're going to learn about radian and degrees. Okay, you'll notice radian is pi. And that's because we're going to be dealing with the unit circle. So remember when you had to find the area of the circle, it was pi r squared. Or you had to find, and the area means like how much is it for the inside. Then you also had to find the circumference, which is 2 pi r, and that's what is the distance around the circle. So you're using pi. Whenever you use pi, that's radian mode. But we're also going to be talking about things in degrees. A circle, while it is 2 pi all the way around, we've also learned that it's 360 degrees all the way around. So this represents degree mode, and this represents radian mode. So when you see 2 pi, you think 360. When you see 360, I want you to think 2 pi. Okay? So that's when we'll talk about going from radian to degree. That's like English to Spanish, Spanish to English. Another big thing that you're going to need to memorize, not this year, but if you're going to go to Calc, it's going to be very helpful to memorize it, is the unit circle. I'm actually horrible at memorizing, so I do everything based on triangles, and I'll show you how to do that as well, just because I'm not good at memorizing. The truth is, for this year, you're going to have this right in front of you, so you won't feel like you need to memorize it, but if you know that you're going to be taking a summer pre-cal or taking calc eventually, you'll want to memorize this unit circle. Okay? So this page is very valuable. All right. So we've learned about sine, cosine, and tan. Now we're going to learn about the inverse. The inverse of sine is cosecant. The inverse of cosine is secant. The inverse of tangent is cotangent. And if you look, I know you say sin, but it's sine, cosecant, cosine, secant, tan, cotan. Everybody, a lot of people don't struggle with remembering these two go together, but it's remembering that these two go together. So if sine is opposite over hypotenuse, that means cosecant is hypotenuse over opposite. Okay? If cosine is adjacent over hypotenuse, that means secant is hypotenuse over adjacent. If tan is opposite over adjacent, that means cotan is adjacent over opposite. Okay? So, what do I remember? I remember when I have a cute little triangle that my hypotenuse is always my longest side. That's my H. And that has to do with sine and cosine, so that's a reminder. And then this L represents your opposite and hypotenuse. Opposite over adjacent. Opposite over adjacent. Okay? So, now that we're doing that, they're going to ask us to use these trig ratios to find the value of theta. We're we'll find the value of theta, but we'll do it later. So right now, all I want us to do are the ratios, okay? So I'll start with sine because I feel like it. So I go sine of theta. Theta represents the degree. We don't know the value. We eventually will be finding how many degrees it is. Right now, we're just setting up the ratio. You've done this before. Sine is opposite over hypotenuse. So I'm going to write that. And we're just going to leave it like that for now, okay? Cosine. Adjacent. Adjacent means next to. Well, this is next to also, but that's the hypotenuse, remember? That's the hypotenuse. Okay, so that would be 14 over 50. And then tan of theta equals opposite over adjacent. The problem is, with all of these, what can you do? You can simplify. I can divide this by 2, I can divide this by 2, and I can divide this by 2. Now, I want to show you a different way. What I'm going to do is I, from the beginning, am going to divide everything by 2. If I did that from the beginning, then I wouldn't have to simplify all 3. So I could say that's 24, that's 25, and that's 7. And I don't know if you remember, but a 7, 24, 25 is a special triangle. Okay? So that means that I, from the beginning, probably wouldn't have done this. I would have simplified from the beginning. Sine is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And now that I did sine, cosine, and tan, now I'm going to do cosecant, secant, and cotan. So I go CSC theta equals, and I just flip it. Comma. Secant of theta, flip it. Do the inverse if I'm being fancy. Cotan of theta equals 7 over 24. Okay? We're not going to find the value right now. I just want you to set up the ratios. That makes me happy. Set up the cute ratios. All right, let's look at the second one. How does the second one differ from the third one? Well, it's different because they didn't give us the third side. So I can do the Pythagorean theorem. But I don't know about you, the 24 and the 32 seem kind of big to me. I don't want to do 24 squared. I think of a number that can divide into 24 and 32. The biggest number, and that's 8. So that's really 3, and that's really 4. Ah, okay. That means it's a 3, 4, 5. Does that mean that the length of this is 5? No. It means the length of this is what? 40. Because if we went from here to here and we divided, then we go from here to here and multiply. I need you to put that third side in there so that I know that you know that the length isn't actually 5. And then now I do sine of theta, cosine of theta, tan of theta, cosecant of theta, secant, of theta, tan of theta. Okay? I encourage you to fill that in yourself right now. Okay? So now if you look, and I should be highlighting this so it's clear, here's my theta. So here's my theta. Okay. And in each of the answers, when I find the value of theta, it should be the same. Okay. So now I'm going to do sine. Sine is opposite over hypotenuse. That means that's adjacent over hypotenuse. And then opposite over adjacent. Now I flip, flip, flip. Okay. Now what I'm going to do is actually figure out the value of theta. Let's see if you remember. So which one do I pick? This one, this one, this one, this one, this one, or this one? I always just pick sine. Okay? So if I'm going to find the actual value of theta, I have to do the inverse sine of 24 over 25. So I'm going to do that right now on my calculator. Okay, so I go to functions, I come over here, oh, it's right there, inverse sine of 24 divided by 25. But it says 1.2. What am I trying to figure out? I'm trying to figure out my degree. Is my degree 1.2? No, because I'm in radian mode. That means 2 times that will give me the answer. So I don't want it in radian mode. If you remember, when I want a degree, I have to go down here and I have to change that to degree mode. Once I change it to degree mode, I get the answer, which is 73.74. Let's round to the nearest tenth. So 73.7. Theta equals 73.7 degrees. How are we doing? Hopefully okay. Now I'll come over here and I'll do the same thing, inverse sine of 3/5. What was that, 3/5? I don't know. I'll look again. Oops. I'm doing awesome. Yeah, it was 3/5. 3 divided by 5. And if I'm rounding that, that's going to the nearest tenth at 36.9. So I did the inverse sine of 3/5 equals theta. And then theta equals 36.9 degrees. Now some of you go, why didn't you pick cosine? I could pick cosine, okay? So I could come over here and I could pick cosine. Let's see if okay, I'll just start again. Functions, inverse cosine of 4/5. And you're going to notice something weird, and we're going to talk about it later. Okay, so just right now, say sounds good. Okay? All right. So now we're going to come over here, and we're going to do this one. What's the problem with this one? I don't have the third side. But not only do I not have the third side, you know what? I'm actually going to make this a 6. And I'm going to make this a 10. So let's change that to 6 and 10, please. Okay. Not only do I not have the third side, well, actually, that's it. I just don't have the third side, but I don't want to do 6 and 10. So I divide by 2. That means that's 5. And that means that's 3. Is this a 3, 4, 5? No, it's not. So what am I going to have to do? I'm going to have to do the Pythagorean theorem. You do that right now. So I get the square root of 34, but that's what my green is. So what does that mean my actual length is? 2 rad 34. But I'm going to focus on my green, okay? This one's going to be a little bit more different. Oh, by the way, I've got to see if I can birthday cake, and I can't. So, because that's 17.1, there's no double, so 34 is done. So I'm going to go sine of theta equals. Let's go to my theta. Okay. Opposite over hypotenuse. What's the problem with this one? Yeah, I can have a rad in the denominator, multiply it by itself. So really, it's equal to 3 rad 34 over 34. Okay. Do cosine yourself, please. And you would get 5 over rad 34, which equals 5 rad 34 over 34. And tan of theta equals 5/3. Okay. I did sine, I did cosine, I did tan. Now I'm going to have to do the flip. Well, if I flip, I want you to see. If I flip this answer, 3 rad 34 over 34, if I'm going to find the cosecant, and I flip it, that's really 34 over 3 rad 34, and then I have to multiply by rad 34, and then I get 34 rad 34 over 3 times 34, which is 102, and then I divide by 2, which is 17 over 51, and then I think I can divide by 3, I don't even, and that's 1/3. Okay, this is too annoying. So then I end up with rad 34 over 3. And some of you go, what? I agree. So what I want you to do is when you're doing cosecant of theta, I don't want you to flip this. I want you to flip the beginning. Okay? And if you flip that, it's just rad 34 over 3, which is what I got after this hot mess. So let's look at cosine. What's the inverse of cosine? Secant. Do I want to flip this? No. I'm going to flip this, which is rad 34 over 5. And then tan, the inverse of that is cotan, which is 3/5. Okay? So I should have circled that. And now I can find the value of theta. You get the game. Okay? But what I really want you to get is being able to write these as ratios. All right? There's going to be a lot of little videos, so I'm going to pause it.